Let's find all of the fifth roots of negative 8 plus 8i square root of 3, and then we'll use this work to get the one definition of minus 8 plus 8i square root of 3 to the 1/4. So this is an important distinction in terms. When we solve the first equation, we're solving for z to the fourth is equal to negative 8 plus 8i square root of 3. And of course, this must have four solutions. One of these four solutions will be the answer to the second part of the problem. Okay, so to do this, let's write z is equal to r e to the I theta. And on the so the right-hand side becomes r to the fourth times e to the 4i theta. The right-hand side becomes negative 8 plus 8i square root of 3. In the complex plane, that will be up here someplace, where the distances are negative 8 and 8 square root of 3. And so using trigonometry, this angle here would be 2 pi over 3. So we have that negative 8 plus 8i square root of 3 is equal to 16 times e to the 2 pi I square root of 3 over square root of 3. So 16 times e to the 2 pi I over 3. Okay, so these two complex numbers must be equal. The way that these happen is if that the moduli are equal, so r to the fourth must be equal to 16, where r is positive, and the angles have to be coterminal, so that 4 theta is equal to 2 pi over 3 plus 2 pi n. In other words, we need that r equals 2, the ordinary fourth root of 16. And we also need that theta is equal to, dividing by 4, we get pi over 6 plus pi n over 2. And we will let n be equal to 0, 1, 2, and 3 when doing this computation. So first off, n equals 0. This gives that z is equal to 2 times e to the I pi over 6. Or in other words, 2 times the cosine of pi over 6 plus I sine pi over 6 which is 2 times the square root of 3 over 2 plus I times a half, which is square root of 3 plus I. And before we continue with the problem, this is the answer for the second part. So negative 8 plus 8i square root of 3 to the 1/4, that is the one that we just got. So the n equals 0 case when doing this calculation is the definition of what negative 8 plus 8i square root of 3 to the 1/4 power means. Okay, now let's get the other cases. N equals 1. Pi over 6 plus pi over 2 gives me 2 pi over 3. So z would be equal to 2 times the cosine of 2 pi over 3 plus I sine 2 pi over 3. And that's equal to 2 times negative 1 plus 1/2, pardon me, 1/2 plus I times the square root of 3 over 2, which works out to be negative 1 plus I square root of 3. 2 more to go. n equals 2. Z is equal to, if n equals 2, we get 2 pi over 2 for pi plus pi over 6 for 7 pi over 6. So 2 times the cosine of 7 pi over 6 plus I sine 7 pi over 6. And this works out to be 2 times negative square root of 3 over 2 minus I times a half, which is negative square root of 3 minus I. And finally, for n equals 3, if we put 3 here, we have 3 pi over 2 plus pi over 6. That works out to be 5 pi over 3. Plus I sine 5 pi over 3. So that's equal to 2 times 1/2 minus I square root of 3 over 2, which is equal to 1 minus I square root of 3. Okay, and before we finish, let me actually plot these and see where these 4 numbers appear in the complex plane. So if we have the complex plane, the first one in green is at negative square root of 3 plus I. The second one in orange is at negative 1 plus I square root of 3. The third one in purple is going to be at negative 3 minus I. And the fourth one in brown is at 1 minus I square root of 3. And these 4 points form the edges of a square, which is not too surprising because I'm rotating by 90 degrees to go from one point to the next. And furthermore, all these points lie on a circle. So if I were to draw a circle, I'm probably not going to do it very well here, but if I draw a circle, this circle has radius 2 because all of these points have a distance of 2 from the origin. So that is the geometric positioning of the 4 roots of negative 8 plus 8I square root of 3. And the unique answer for negative 8 plus 8I square root of 3 to the 1/4 power is the one when I let n equal 0, and that worked out to be negative 3 plus I. And let's actually see if the calculator actually gives the right answer here. So if I take negative 8 plus 8I times the square root of 3 and raise it to the 1/4 power, we get what we expected to get, square root of 3 plus I. Square root of 3 plus I. So that's the answer that the calculator returns, and it matches what we have right here. The calculator, of course, does not return the other 3 values, which we had to compute using de Moivre's theorem.